Hey guys, Rudy here with a CSSE 1001 and 7030 tutorial solution video. So basically I like to go through the tutorials each week and sort of put together my thoughts, my solutions, and sort of step through the process that I do to come to that, explaining some functions and some concepts along the way. Yeah, so basically if you missed a tutorial or you weren't quite sure about some of the solutions, or you've gone and had a good look at the online solutions that we post and you're still not quite 100%, feel free to step along with me. I encourage you to still always attempt the solutions, attempt the tutorials before watching this video, looking at the solutions. But yeah, it's just an additional resource for you guys, really, just to get a bit of extra, I guess, perspective on solving these problems. So we're here with the first tutorial, the week 2 tutorial, and let's just get straight into it. So we got first here, hello world. So we're just looking to get familiar with some of the basic text sort of output stuff that we have going in Python. Okay, so we want to write a program which, simple enough, when runs, outputs the text hello world, okay? And save it as hello py. Well, mine's going to be week2 shoot.py, but call whatever you want. So as you guys have probably worked out by now, whenever we want to stick text up on the screen, we want to use the print function. Hello world. We wanted a comma there. Okay, so the print function lets you do a couple of different things. Oops, I've mixed my quotes. Make sure you don't mix your quotes or it won't work. Print function lets us do a couple of things. So we can run our print program like this. And we can see it spits out hello world. But the print function's a little bit, we've got a couple of different ways we can do this, right? So we can try printing hello, and then we can actually give print two separate arguments or parameters. That's what we call these things that we're feeding into the function. So notice how this is one singular string and this is two different strings. But when we run the program, they give us the same output, right? And something else we could also do with the strings is we could build them up using the plus operator. So if you guys haven't seen that before, we can build or concatenate, is the technical term, some strings together using the plus operator. And let's get our space in there, and let's try printing that as well. Okay, so we can see we've got several different ways of doing the exact same thing. And for now, like, these ones might not look very useful now, but down the track, when we have different variables and different sort of unknowns coming into play, all of these three different methods of printing stuff can be pretty useful. Okay, so let's keep going here. What do we want? We next want to modify the program to first ask the user what their name is, and then output a greeting using their name. Okay, so let's just comment that out. So we want to ask the user for their name, or in other words, we want to get some sort of input from the user, and that's our keyword there. So the way input works is it allows you to allows you to receive input from the user, and we can also give it a string here to get it to ask a question or to output some sort of information first. So we want what is your name? Okay. We run this and we can see that it's giving us the blinking cursor, like Python is asking us for input. And I can go Rudy, and then it doesn't do anything because we haven't told it to do anything yet, right? So if we want to capture the input that we're getting from here, then we need to store it in some sort of variable. Okay, now I'm going to use name because it's a name. We always want to use nice, clear variable names so that our code becomes more readable and we can come back to it in a couple of weeks and know what's going on. So, something like variable 1, not a very good name, right? Doesn't really tell us what's happening here. But if we store this name, we can get the name from the user input, and then let's just try printing that straight back out. Rudy, and it's stuck it right back out for us. Okay. So using some of these previous print methods where we used up here in the first question, we can actually sort of customize this a bit to get it to print back out hello and what is our name. Okay. So using this first method we've got here with print, we can go hello, and then what's it, a comma? And then we can stick in the name variable, right? And then that's going to put hello name. Whoops, let's not save. What is your name? Rudy. Hello, Rudy. Okay. Now, I think I actually saw an exclamation. Yeah, we saw an exclamation point there, right? So we could try chucking in one extra thing like this. But we'll see when we run that it's actually put in a space. And print is chucking a space in between all of these different things we give it. So we don't necessarily want to be using that here, right? We can instead look at using these plus signs to sort of mix and match. So if we don't want to stick that space in there, let's just stick the exclamation mark together here. And we can do the same here as well. Okay. And Rudy. And now we can see that it doesn't have the space on the comma side here, right? Because I got rid of it. So let's just chuck that back in. One last time. Rudy, okay? Another little trick you'll see here is it puts the cursor right after our input string. So if we put a little space in there, it looks a lot nicer, just presentation. Okay? So that's just a really sort of basic, having a bit of a play around with strings and print and input there. Now, so let's step over into this guess the expression now, okay? So I'm going to actually just use purely the shell, which is this guy here. So the shell is really useful if you only need to input 1 or 2 commands at a time. Anything more than that, and we probably want to use the script file that I've been using over here, right, where we sort of write down several commands and try and run them. But I'm just going to step through the shell now. I'm just trying to clear it because I don't want to be up the top. Okay, there we go. Oops. Let's just comment this out for now. Actually, you know, something else you can do is you can actually get a blank shell from here. So let's get that shell in and try looking at some of these commands. Now, most of these are fairly straightforward, right? Like Python is working basically the way you'd expect maths to work, right? We can see we're just going through fairly standard maths, minus, -2, 5, division, division's working 5. Now here's the first one that's a bit interesting. This double slash here. Now this is known as integer division, or if you're a bit more familiar with some of the maths, there's also floor division you might have heard of. Essentially all we're doing here is we're doing normal division, but then we're making sure our number is an integer by rounding down. So 5 divided by 2 gets you 2.5, and then we're rounding down until we hit an integer. And we can see we're always returning this integer 2 here, okay? So you might have been expecting this to be -2, right? But if we sort of think about this a bit more carefully, we can see that -5 over 2 is -2.5, and then we round down. In other words, we round towards the negative side, okay? And we can see that in that way, we're going to be rounding down towards -3, okay? And yeah, stuff like adding in those decimal zeros isn't really changing anything. Something to note here, for instance, is that if you put in, this is called a float, right? It stands for floating decimal point, I think. Basically, whenever we need to use decimal points in our numbers, Python will, by default, if you include a float in one of your operations, Python will give you back a float answer, okay? So we can see here, it's put this in, and we've gotten out the float 2.0 as opposed to 2. Really just small semantic things, but you know, good to know. Order of operations applies in Python. Oops. We can see we've figured out the 2.5 first before getting the 3, so we get 3 minus 2.5, 0.5. Nothing too weird going on here. Same with these, right? They're all working pretty much exactly how we'd expect the maths to work. Okay? So let's head down into some of the more interesting stuff. Okay, 312. Now we saw in the previous one that I was using the plus sign to build up strings, right? And we call this process string concatenation, right? And it's exactly the same here, right? We might think, oh, but it's the number 3, it's the number 12, but it's not really, right? We've got these quotey guys around it. I'm doing the air quotes at the moment. I realize you guys can't see that, but you know. We've got these little quote guys around it, so it's a string. It's not a number. This is no different to trying to stick together a bunch of letters, right? So the more interesting sort of thing comes when we try and mix and match these guys, okay? So 3 and the string 12. Python says no, okay? Unsupported operand type for plus, int and string, right? In other words, we can't use the plus operation on integers and strings. Okay, and if you stop and think about this for a second, this really makes a lot of sense. Like, how do you add a word to a number? right? You might think, oh, but this is the number 12. But once again, we've got these quotey things, right? What if I was trying to add 3 to fish, right? It doesn't make sense for this operation to exist, and so Python will fail, right? Python will tell you no. Some other useful stuff we can do, though, is we can multiply strings, okay? And you think about the reason this works is because multiplication is really just a series of addition, right? So the moment we try and start doing stuff like this, we can build up strings really quickly and easily. And this might actually be fairly useful in your assignment 1. You know, maybe you want to be multiplying underscores for your guesser and checker there. Hint, hint, nudge, nudge. Of course, there are heaps of other ways to do it, but that is one cool way. And yeah, once again, our order of operations. Whoops, that was a times. Coming into play as well. So, na, and then plus the bar, banana. Now, can we subtract strings? No, we cannot, right? And you might think, oh, but there's an O at the end. Why don't I take the O off? But you have to think a bit more generally. Like once again, if I have fish, and I try and subtract, you know, Napoleon, what's that supposed to give me, right? It doesn't really make sense for this operation to exist, and so it doesn't, right? It's not coded into Python. In exactly the same way, we run into the same similar sort of problem with division of strings, right? Like, even though this particular string happens to look like it can be broken up into parts, something like fish divided by 56 doesn't really make sense, right? And now we've got this weird double star thing. And you might go, 8, where did that come from? And basically, double star is to the power of, right? You'll find in Python that the thing that you think looks like to the power of doesn't give you what you're expecting. And that's because it's something else called bitwise XOR. You don't really need to worry about that, but you can always go off and if you're interested, have a bit of a Google of XOR, exclusive OR. Or if you already know what that is, then that's how you do it. But otherwise, yeah, we do our powers of using the double star operation in Python. Okay, so, you know, 9 to the power of half should give us what? Square root of 9 is 3. But we've got a 4.5 here, so what's going on? Now, like I said before, we've got order of operations in Python, and the double star is taking precedence. So what's really happening here is something that looks a bit more like this. Okay, so if we want to get our desired result of 9 to the half and, you know, try square rooting stuff, we've got to be really explicit with our brackets. So there we've got our root 9 is 3. Okay, only a couple more, guys. So percent sign, what is percent sign? If you're familiar with the maths here, once again, if you've done math 1061 or you're looking at doing some of the other maths subjects, I guess, this is modulo, okay? And basically this guy is the pair operator for the double slash, the integer division. Now, what do I mean by that? Essentially, I'm just gonna get up somewhere where I can do a bit of typing. So when we do 11 divided by 4, right? Now think back to your old school division, right? When before we really knew what decimals were, and it was back in primary school. And we would say that 11 goes into 4 2 times, right? So another way, it goes into 4 2 times, and then what's left over? Remainder 3. Okay, so we would often write something like this as 2 remainder 3. Actually, let's spread that out. So what, 2 times 4 plus 3, and we say that that's 2 remainder 3. And so this percent sign, this modulus, is giving us the remainder when we do our division, right? So we divide 11 by 4, we can get 4 plus 4 is 8, we've got 3 left over, and so that's what our percent sign is, okay? This is a really useful operation, for instance, in determining parity. So if we try and do mod 2, we either get a 0 or a 1, right? So if we get 0, we know our number is even. If we get a 1, we know it's odd. Stuff like that, right? We can use this. It's a deceptively powerful operation, and we'll be using it in some of the future exercises. But that's the maths behind it, right? So if you're still unsure, you want to look up the actual maths. You can look up modulo or modulo arithmetic. Hope I spelled arithmetic right. I don't know, something like that. But yeah, it's the modulo or modulus, something. Basically, if you look up mod, you'll find it. If you look up the percent sign in Python, you'll find some more explanations. But basically, it gives us the remainder when we divide. Okay? Now, interesting side note from maths is we can see that this has given us a different answer to 11 mod 4, right? And this is because in when we do the maths here, the remainder is always a positive number, right? So if we think about negative 11 divided by 4, we can count up negative 4, then we can get negative 8, and then finally we get to negative 12, right? Because we need to make sure that our remainder is a positive one, right? So we end up with 4 times negative 3 to get to negative 12, and then plus 1, right? In other words, negative 11 divided by 4 is 3, remainder 1. Okay, so the remainder isn't guaranteed to be the sort of symmetric when we take the negative, right? When we go from 11% 4 to a negative 11% 4, we're not guaranteed to get the same remainder. Because our remainder, like I said, always has to be positive. So we can't just mirror it. Okay. And finally, we've got some stuff happening here. Tim greater than Tom. Nope. Sorry, Tim. Tom is greater than Tim. What is happening here? Basically, every letter when we code every letter in Python has an assigned number value in the background, basically, that Python is using to sort of determine how big they are, I guess would be the word, and to determine a sort of order. And so I'm just going to bring up this table here quickly. So this is known as the ASCII table, right? It's like American Science and Computers, something or other. You can Google ASCII, ASCII, right? You can have a look at ASCII. You can see Python has even realized that it's special. And it's given us a bunch of different characters and stuff here. I'll try and zoom in a bit. Okay, so we can see that big T comes back as what, number 84? Okay, and so, well, the big T here and the big T here are obviously going to match, right? And so we just think about doing this logically. It's then going to move on to the next letter. Okay, so let's think about the I and the O. And the little I is, I believe, somewhere off to the right that I've zoomed off of. Yep, so here's our little I, 105, and here's our little O, 111. So if you think about it, we're just going in alphabetical order, really. But the I comes before the O, so this one is smaller than this one, right? Or in other words, I smaller than O. Python says yes, okay? So we've got one other thing happening here, big A versus little a. And that's coming back as true, and we can just see pretty easily, once again, from getting that table back up, that we have just got that all the big letters, or all the uppercase letters, come first in the alphabet, and then all the small, or the lowercase letters come, right? So basically any uppercase letter, when it gets converted to sort of look at this table, is going to come back as smaller than a lowercase letter, okay? Don't need to worry too much about that. But essentially, we can compare letters in alphabetical order, or words in alphabetical order, as long as we keep our case consistent, so all uppercase or all lowercase. So we're just aware of what can happen here, okay? But yeah, basically allows us, apple less than zebra. Yes, apple does come before zebra in the alphabet. Okay? So let's get back into writing some code here. So what's our next exercise we've got? Oops, I just closed that. Let's get that over to the side. Okay? Leap years. A leap year occurs when the year is a multiple of 4, unless the year is a multiple of 100. However, if the year is a multiple of 400, then it is a leap year. Okay, so we've got a couple of rules here. Fairly simple rules, but we've just got some very clear rules that we should be able to use to write a function. So whenever we want to write a function, remember we start with the def keyword. Is leap, oops, that's not an underscore, is leap year, which takes an integer. So I guess we'll call this year. Okay, remember the colon and then indent. Okay, and now we're clean to write our code. Write a function is leap year, which takes an integer and returns true if the year is a leap year. Okay, so we've essentially got 3 questions here, right? If it's a multiple of 4, unless it's a multiple of 100, then it's not. But then if it's a multiple of 400, then it is. Okay, so you might be sort of tempted to, well, I guess first things first is how we're going to figure out if it's a multiple of 4. Now, when we were doing these, right, I sort of harped a bit on this percent sign, and this is one of the reasons is it allows us to calculate divisibility. Because if we think about it, if we divide something and we get a certain remainder, we can actually tell whether a number is divisible by another number, right? Because if we divide and there's no remainder, right? In other words, the number cleanly divided into the other number, the operand, then we know that it is in fact divisible, right? So let's just think about this. You know, if I divide 6 by 2, right, and then I take the remainder, it's going to be 0 because 6 cleanly divides into 2. Or if I take 2000 and I check if it goes into 400, 0 again, right? Because we're getting no remainder. So if we want to check if something is divisible by 4, all we need to check is if its mod 4 is 0. Okay? So we've got these guys here. What was the other one? We had something to do with if it's divisible by 100, and if the year is divisible by 400. Okay. Now, it's all good to ask these questions, right? But we can't just determine straight away from some of this information whether our year is a leap year or not, right? So for instance, let's think about this. If we know that the year is divisible by 4, can that straight away tell us if we have a leap year or not? Well, no, not really, right? Because let's think about it. We get the year, 1996, right? That's divisible by 4. But do we straight away know if that's a leap year? Well, that one happens to be a leap year. What about the year 1900? That's divisible by 4. Is that a leap year? Well, no, because it's divisible by 100, right? And then we think about the year 2000. Well, that's divisible by 4, but it's also divisible by 100, so it's not a leap year, but it's also divisible by 400, so it is a leap year. So you really got to be thinking about the order in which these questions need to be asked. Now, straight up, if we know something's divisible by 4, that doesn't tell us straight away if it's a leap year or not, right? So let's just move. Oops. Let's just move this out of the way. If we know if the year is divisible by 100, does that straight away tell us? Well, 1900, yes. 1800, yes. But 2000, no, right? So there's still some ambiguity here. It still could be or could not be a leap year. Now, if we're divisible by 400, are we guaranteed to be a leap year? Well, 2000, yes. 2400, yes. We are 100% guaranteed. If we have mod 400, we are guaranteed to get a leap year. So this straight away breaks us up into two categories: things that might be leap years and things that definitely are leap years, and things that might not be leap years. So straight away, if we hit here, we have a leap. We have a leap year. Okay, so we want our function to return true. Okay, because we want a yes. Is a leap year? Yes, true. Now at this point, the next most specific question is this, right? Because that's all we're really doing here. We're going in the order of the most specific question to the least specific question. So if it wasn't, and once again, I'm using several if statements here. Now, let's think about this. If we ask this question and we get a yes, we're going to hit the return, right? So we're straight away, we're going to exit our function and we know we're done, right? We don't even see this here, right? It just wouldn't exist because the function will hit the end. So at this point, if we know that we didn't hit this, then we can safely say at this point here, right? At this point, year was not divisible by 400. Okay? So if we know that it's not divisible by 400 and it is divisible by 100, we know that we don't have a leap year, right? We know that our year is 1900 or something, and then it's definitely not a leap year. Okay? And then finally, once we've exhausted these two sort of options here, we know that if we get a number that's then divisible by 4, then it is, in fact, a leap year. Okay? Now, so let's sort of think about this function at the moment here. We've got an if, and an if, and then, well, we still haven't sort of, what if it's none of these cases, right? What if it's not divisible by 4, 100, or 400? Well, then it's a year like 2001. It's not divisible by 4 or any product of 4, so false, nothing. Okay? Let's test this. A few inputs. So, where's my shell? There we go. Is leap year 2000? Yes. What about 2100? No. Cool. What about 2001? No. Okay, so it looks like it's working. We could go through and test a few more outputs, but this is a fairly safe way of doing this, okay? Now, it is possible to make this a little bit shorter if we want, right? So I'm actually going to sort of... Here's leap year 2, right? I'm just going to write another quick one showing a slightly different approach to this. Now, we've asked several different questions here in one go, right? And that's great, but we can potentially ask one slightly more complex question, right? And in turn, or it's like one slightly more complex question, and then in turn sort of cut down on the lines of code we're using here, right? So if instead we were to think about this, we want a year that is what? We want a year that is divisible by 4, and then either divisible by 400 or what? Not divisible by 100. Okay, so that's essentially what we're looking for here. And we can use the AND keyword and the OR keyword to sort of chain together these questions into one if statement. So we definitely want a year that's divisible by 4, right? And then after that, we could have and what? We want to make sure that the year is either what? It's either, oh, whoops, divisible by 4. I need my equals 0. Whoops, do. Okay, and after that, we would want a year that is either divisible by 400 or the year is not divisible by 400, in which case our year, our modulo would not be equal to 0, right? I might actually just squeeze this guy together a bit so it fits on the screen in one go. Okay, that's unfortunate, but yep, there we go. So let's think about this. If the year is divisible by 4 and either the year is divisible by 400 or, that's a typo, or the year is not divisible by 100. Okay, because if it's divisible by 4 and it's either not divisible by 100 or it is divisible by 400, then we know that we have a leap year, right? And then in all other scenarios, we don't have a leap year, okay? So this here, it's using what we call Boolean logic, sort of. We can chain together these different conditions. Notice here I've used my brackets as well to sort of say that I want all of this encapsulated in one, and then this as a sort of separate condition, okay? And we can see how this sort of covers all our edge cases, right? Because we need both of these things to be true in order to get a leap year. So, you know, if it's not divisible by 4, straight up we know it's not a leap year, right? So this one would be wrong, and then the question's over and we get return false. But just because it is divisible by 4 doesn't necessarily tell us straight away if it's a leap year. We need to sort of incorporate these two questions into the rest of the if statement. Okay, and so let's just have a bit of a run with this. Is leap year 2 still false? That's true. 1900, false. Okay, so it's just another way of approaching it. We can see that it's a lot shorter lines wise, right? Like this one was quite long and this one was basically one line. Okay, and then yeah, after that, it's basically we've traded complexity versus code length, right? We made it a bit more complex, but we've shortened the length. Okay, you can look up this Zeller's congruence. It's a bit of a formula that you can sort of try and plug into Python using basically the % signs and probably some division and stuff. I'm not going to look at that at the moment because it's pretty much the same thing. We're instead going to move on to Alice's Addition Academy. I'm actually going to call this part 1 for now, and so stay tuned guys and we'll be right back with part 2.